We're going to change up our speakers here a little bit. Manny has a drive back to the south after this, so it sounds like the weather is a little bit worse to the south, so we're going to get him out of here a little bit quicker, and hopefully we can get out of here a little quicker. So our next speaker is Dr. Manni Singh from MSU. Dr. Singh's research, extension, and teaching programs focus on current and emerging issues in cropping systems of Michigan, with an overall goal to improve the profitability and sustainability of these systems. Current research is focused on management practices such as planting density, precision planting, tillage systems, and plant disease interactions in corn, wheat, and soybeans. And it's based on wheat cropping systems. So I'm going to turn it over now to Manni Singh.
All right, I drove from Lansing just before noon time, and it was icing over there. So hopefully it's not too bad when you guys start driving. Everyone hear me okay? Still, right? All right. So again, first of all, I would like to thank you all. Your check of dollars help fund the work we do, right? So when Jody asked me to come and talk, I was like, okay, this is a good opportunity for me to come here and talk to you about what we have been doing. So I think I would also like to acknowledge Dennis Pennington. He helps us a lot with implementing a lot of our research, and the grad students in the program who help us get things done. All right, let's get started. So in our program, we think about wheat in terms of maximizing the yield potential, right? So these are if you look at this, these are the three key terms that you will hear over and over. I feel like they still echo there. Okay, how about now? I think this is better because I was hearing myself. Okay, I think this is better now. All right. So in terms of, again, wheat yield potential, right, we need these three things. Number one, we need to maximize the amount of sunlight intercepted by our canopy early in the growing season, right? That's your first term over here. Number two is we need to convert that sunlight into biomass, right? That's the use efficiency of that light. So making sure we are not at the bottom of our canopy, we are not shading those leaves, right? That's a way to maximize conversion of light into biomass. And then number three is we need to convert that into our grain yield, right? That's our goal. So if we can maximize these three terms, that maximizes our yield potential. And to do that, again, is if you look at this picture, that's a nice looking canopy, right? That'll help you, again, intercept more light, convert into usable biomass, and then that seed yield. So the question is how we get there, right? So in our program, we focus primarily on these planting decisions, right? Because we are setting our yield potential at the time of planting, right? And then we are trying to protect that yield potential over time, right? So again, this year's crop is in ground, but again, I'll give you ideas to think about, and there might be a few things that can be implemented even in this year's crop, right? So here we go. Number one, when we think about this designing ideal canopy is the planting time, and I'll show you why that is very important. Next one is planting method, how we are putting that seed in ground, right? The precision of that placement and how quickly we can get it done, right? And we are thinking again, row spacing is a component there, seeding depth, and that seed-to-seed spacing, the singulation, right? That we have been able to achieve in corn and soybean, but in wheat, we probably are still not there. And then the third, or I would say the most important, is the variety selection, right? You all have your, again, 5-10 key ideals, that you think through while picking a new variety. I'll give you one more. I believe Eric probably already talked about this, the variety canopy type in the morning. So I'll give you a little bit more about how that fits into designing this ideal canopy, right? And then the last one is the seeding rate, right? That component interacts with everything else that I already showed. So in our talk today, we'll spend about maybe 10 minutes each on these three components: planting time, planting method, and then this variety selection in terms of that canopy types. All right. And if anyone has any questions, please feel free to jump in, all right? I'll be more than happy to answer anything as we go through these slides. So again, starting with the planting time, right? You all probably have heard and seen a figure like this. A good rule of thumb for wheat planting that we recommend is go by the Haitian fly-free date, right? The yellow dwarf, barley yellow dwarf virus is not a concern, but again, it's still a good rule of thumb to start planting wheat. And again, I'll show you some data why that is the case, right? And then we know, again, Mother Nature plays around, right? That we can't get to field when we want to. So what do we do in that scenario, right? What sort of yield penalty we are looking at when the planting gets delayed? And then do we need to change any other management to minimize that yield penalty, right? So again, if you look at these dates around here, that's around third week of September or so, and then it gets delayed as we move further south, right? So we have done planting date work over the last 3 years. So in this slide, you can see we did it over the last 3 years, 2020, 21, and 22. We were targeting 5 planting dates, starting with, again, that soon after Haitian fly-free date, mid-September for Ingham, Lansing area. And then going about 2 weeks or so, right? Early October, mid-October, then late October, and going all the way into mid-November, right? You can see our actual dates for all the 3 growing seasons. We were within a couple of days of our target, right? The idea was to, again, let's figure out what sort of yield potentials we are seeing across these planting times. And then we paired that with seeding rates. Here you can see, again, we went all the way as low as 0.8 million seeds, and then as high as 2.4 million seeds to catch the lowest and the highest end of typical seeding rate practices, right? Little other information, again, this trial was done in Lansing area using a whitetail variety, around 150 pounds in total, right? And was under conventional tillage. All right, so looking at the data here, starting with, again, the planting time impact, right? So here you can see planting dates on x-axis, the yield. This is percent or maximum, right? So it's a relative yield. 100% means that we were maximizing. That was our maximum yield. And it varied anywhere from 100 to 140 or 150 bushel in a given year. You can see 3 years in these 3 different colors over here, right? So if you look at this line, you can see the decline in yield as the planting is getting delayed. But then at around somewhere over here, the decline changes based on the year. And that's the weather impact, right? How cold it's going to get in winter is going to determine some of the losses. So when we look at this data, this is sort of how we partition it, right? Right here, this first line, I would say, is pretty much like 1st of October or so. If we are able to plant before that, that's what we are calling our optimal planting window. We are within 10% of our yield potential, right? So if we want to get the wheat in ground by that time. From there until maybe around mid-October or so, now we are getting more yield loss, right? Up to 20% of our theoretical maximum, right? But after this, after mid-October, now you can see we are losing a lot. More than 20%, all the way up to 50% or so as we get into mid-November, right? So something to keep in mind, again, in terms of the planting windows. The data is from Lansing, so it can change a couple of days earlier or later as we move north or south of that latitude, right? And this is sort of the reason why we are seeing that, right? Again, going back to canopy closure, intercepting more light. So this is canopy cover, how much canopy we have in ground based on these 5 planting dates. So earliest planting is at the top and the latest is at the bottom. And you can see our first 2 planting dates. We were able to close that canopy, get up to 80% or more very early in the growing season, by late April or so. The 3rd planting date was able to get there, right? And it's able to maintain that decent yield potential. But look at this 4th and 5th. That's beyond that mid-October. We just can't close canopy, right? And that's, again, causing the loss in yield potential, all right? Moving to again, what else is going on? So canopy closure is in part driven by how much tillering we are able to get, right? So these are the same planting dates now. So starting from again the earliest, going all the way to that latest one. And I believe this was taken sometime in early December or so. So if you look at this, for this first, the September or 1st of October planting, you can see tillers here, right? Anywhere from around 4 to 5 over here to about 2 or so over here. Once we get into October, we are able to germinate, but we are not seeing tillering. And anything beyond that, we did not even germinate, right? So again, in terms of maximizing yield potential, typically we want more fall tillers. Fall tillers are the ones that gives us those reproductive heads, effective tillers, what we typically call, right? So again, to get there, we want to probably be over here. These plants will tiller out, but those are spring tillers, and the yield potential of spring tillers is typically lower than what we can get out of fall tillers, right? And that's where the seeding rate component comes into play, right? We typically think now we are delayed, we need to bump up our seeding rate to account for that less tillering, right? So let's look at some of these data. And initially, when we looked at this data, we were sort of surprised. These are the 3 years, right? 3 different colors. And my x-axis is seeding rate, going from less than 1 million all the way to that 2.4 million. If you look at the slope of these 3 lines, it's sort of a flat line, right? You expect these slopes to go up as the seeding rate is increasing, right? So we did not see that here. We tried to partition these data by different planting times. So again, here, these 5 different lines, 5 different colors are 5 different planting times. Early over here, and it's sitting at the top. To this last one is sitting at the bottom, right? So a lot of data here, but when we first saw this, the interaction term, so what we again, when we think about as planting gets delayed, how much seeding rate we need to bump up. When we looked at this data, we were sort of surprised, right? Even at the bottom, you can see some of these lines are still relatively flat. We are not seeing a bump in yield by increasing seeding rate with the delay in planting. And we have been struggling with that. We're like, what is going on here? Maybe those increased seeding rate with the delay in planting is not as ideal. And maybe those spring tillers that we are able to make, maybe they are able to yield pretty decent, right? But here, there's a magnitude difference over here. So just yesterday, I think I finally figured it out. And if you look at this data, this would make much more sense now, right? So same 5 planting dates, going from 1 at the top to 5 at the bottom. Here, my y-axis is actually relative yield, because what we are dealing with is a differing yield potential based on the planting date, right? Planting date 1, 2, and 3 have a much higher yield potential than 4 and 5. So the previous figure was not able to account for that. Here, each planting date is sort of relativized with its maximum potential. So now you can see for planting date 1, the line is relatively flat. And we have seen this over and over again. If we are able to plant in September, we can even drop our seeding rate to 1 million or even less than 1 million. So we are able to get those 4 to 5 fall tillers and maximize our yield potential, going that way. When the planting is getting delayed into this mid-October window, if you remember that second window I showed you, here you can see the curve starts, these 2 curves over here. They're starting to bend downwards at 0.8. But at 1.2 million or so, you're close to maximum yield potential. So that's sort of what we are thinking now. Like for September planting, we can drop our seeding rate close to 1 million or even lower. But when we are in that early to mid-October window, we probably can still get away by 1.2 million or so. It's this planting date 4 and 5. Now look at these last 2 lines. They're starting to bend upwards even all the way up to here at least, right? 1.6 or so. You can gain a little bit even beyond that, but the gain is pretty minimal and probably not worth the seed cost there, right? So now if we look at these data, these is sort of what we are coming up with based on that planting window, right? If we are here, we are maximizing our yield potential anyways, right? and we can cut down on our seeding rate. Here, we are losing up to 10% or so. And maybe we can minimize some of that by going to a little bit higher seeding rate. And once we are in this late planting window, where we have already lost up to 20% of our yield potential, we can benefit or we can minimize that loss by bumping our seeding rate up to some extent again, right? These numbers are lower than what we typically have recommended before. So any questions, comments with these data? Some of this will change again based on your soil type, if you are conventional versus no-till. But I believe these data show the ability of a wheat plant to tiller out, right? And again, compensate even if you're dealing with a relatively low stand. And we see something similar on the soybean side as well. That soybean plant is able to branch out, right? Unlike corn we need to push to a higher seeding rate to maximize our yield potential, right? So this is a little bit different compared to what we have recommended before. Yes, sir?
Have you ever found a year where early planting you got too much growth and lost yield because of that?
So the question is, have we seen a yield decline by planting too early in a growing season? We were going with that mid-September planting, and with that, we have not seen that. But my counterpart, Laura Lindsay at Ohio State, I think I've seen some data from her where they planted first or second week of September. And then they did see a yield decline because you probably are producing too many tillers, and the plant, again, is not able to convert as much biomass into grain yield, right? The third component of yield. So I think there probably is such a thing as too early wheat planting. So sticking with that Haitian fly-free date as a good starting point, I think is a good rule of thumb. Yes, sir?
On the first three headings there, was there any yield difference on them as far as planting depth?
Okay, so the question is regarding planting depth. So in all of this, when we do our research, we try to keep other factors at the same level. So the planting depth, I believe we kept consistent around that 1.25 to 1.5 inch mark, right, Dennis? That would be true, right? So we have done, again, I'll come back to the seeding depth component here in a little while. We are not seeing as much response from seeding depth as we expected, all right? Anything else quickly? Yes, sir.
Back to your fly-free date. It's always been about the same date. What determines the demise of the fly?
So again, the idea, it's not about the Haitian fly per se, right? We are just using that as a rule of thumb, not to plant too early to get too much vegetative growth in the fall. That's the idea. It's nothing to do with the flies being there or not being there, if that makes sense. So we can probably call it just wheat ideal planting start time instead of a Haitian fly-free date, right? Because that's not what we are wondering. Maybe I think. Mm-hmm. Yep. So yeah, I should again, there should be a word here, relative here. It's within each planting date. That's the difference what I showed you here and over here. This is actual yield, right? You can see our actual yield in bushels per acre. Here we relativize everything to a given planting date because each planting date has a different, unique yield potential. So it's relative within a given planting date, all right? All right. Yep. Yep. So 90% of within the planting day 5. That's what I said. So this line, each of these lines has a differing divisor. That's the maximum yield within that given planting date, if that makes sense. So we divide all the data points from planting date 1 to the maximum yield we got from planting date 1. Same thing with planting date 5, we divided everything by the maximum yield that we got only from planting date 5. You see? That's why we are relativizing everything, and that's why these curves look flat, because we are not accounting for that, if that makes sense. All right? So this is, again, to me, this is a better representation of data, because for a given planting date, the yield potential is different. You are right. For PD5, the yield potential is only 50-60% of PD1. And that's why it's hard to see this in the actual yield data. All right? All right. So that was component 1, planting time, right? So now hopefully you all are convinced that planting time is critical, right? Now let's move on. What else, Planting method is the next thing that I mentioned, right? So this is pretty important, right? We want to know how critical is that seed placement in wheat compared to, let's say, corn or soybean, right? So this is what we typically use, a conventional seed drill, right? Where we have this gear that, again, does metering, but it's more of a controlled spill, so to speak, right? So we are not able to get a uniform seed placement in terms of seed-to-seed spacing, like singulations we get in corn or soybean, or even seeding depth, right? So that's why we were interested in comparing that method with other planting technologies out there, right? So precision planting is the one we were interested a couple of years ago. And again, as you all are aware, here you are metering one seed at a time, right? This picture is showing a vacuum is pretty much pulling one seed out and dropping one at a time, right? Which again does work, does a good job in corn, probably does a decent job in soybean, but it's hard to make this technology work for wheat. Anyone has any idea why? Yet the seed is so small, plus we are dropping so many out there, right? We're talking millions compared to 30, 40,000 in corn, maybe 130,000 on the soybean side, right? So the disadvantage, another one here, is that the speed of operation is relatively slow. The technology is still not there, and that's the challenge. So we were looking at, what else is out there. And we did hear from a couple of agribusiness people about this idea, broadcast incorporation. All we are doing is using some sort of a spreading tool. Here you can see a Gandhi seeder here to broadcast that seed. And then using a shallow tillage tool to incorporate it, right? Some people have this technology now for cover crops on their farm. So we were just wondering, how will that compare? How will that do in case of wheat? Because again, the benefit with this technology down here is you can cover a lot of area quickly, right? But the downside, again, as all you can see, is it's going to have a lot of variability, right? There's just no control on seeding depth. So let's see what we find out. This is initially what we used to think, early on. One of my grad students drew this sort of a nice cartoon, that maybe this is what a seed drill does. You have a variable seeding depth, you have skips here, you have doubles, so it's not ideal in terms of seeding depth and that seed-to-seed spacing, right? Compared to, again, if we use more of a precision technology, we can take care of both of those issues, right? Now, well, does that benefit a wheat crop? We'll find out. The downside, again, what we are seeing recently, and I assume Jeff did talk a little bit about that in the morning, we are getting more water in our system, especially when we don't need it. This is your number of field days we can have during that wheat planting window, mid-September to end of October. And if you look at this trend line, you can see it's going down. We used to have around 40 or so early in 2000s. Now we are down to around 30, 35 or so. So we are losing number of days we can be out there planting, right? That means we might be able to benefit from using a faster planting technology to get wheat in ground relatively quickly, right? Or if we are using a slow planting technology, it might not be beneficial for us, right? Because if we delay planting, we are getting a yield penalty just because from that, right? Even if we improve our seed placement, as I showed you before. So again, here is some equipment that we used in our research. So again, our control was drill over here, right? A conventional drill. We have had air seeders at a couple of our locations. These trials were done on farm. We did this work on precision planting, starting with a small plot work, okay? And then we wanted to take it on farm, see what happens if we use the technology you guys are using out there, right? At a couple of locations, we did use our packet planter to simulate drill. And this was the precision planter we were using, a custom-built system that Dennis worked on. And it could plant anywhere from 15-inch row spacing all the way down to 5 inches. So we can manipulate row spacing component as well, right? While here, we are always 7.5 inch. And then the third one was this broadcast incorporation idea, right? So you can see we have an air seeder, and then we have these different tools, a joker here, we have a Dagelman here, and then we have a vertical tillage tool over here. So we did these trials over multiple farms. The technology was different at each of these farms, but the basic idea was again the same, right? So let's see, here is a couple of pictures. In drill, you can see the canopy here. You can see 7.5 inch row spacing. This is coming from monosim and narrow row spacing. All right, and this is what we were getting from that broadcast incorporation. So you see there's a lack of row spacing here. So in theory, again, and we'll see what the data looks like, this canopy looks pretty good, right? As long as we can uniformly and randomly distribute that seed out there, right? So let's see what we were finding out. So number one, again, did we improve our seed placement? So my grad students went out and dug up a lot of plants to look at the seeding depth, right? Here you can see a couple of those plants, and you can see the variability in them, the length of the seedlings. Compared to this is coming from a planter. Here you can see everything looks pretty consistent, right? So we did find out that when we used a planter, it did improve, or it minimized the variability in seeding depth. We did improve that by quite a bit. In terms of this plant-to-plant spacing or the seed-to-seed spacing, you can see this looks pretty nice, but it wasn't as consistent. We did lower the variability, but it wasn't much different than the drill. And that again goes back to we are throwing so many seeds out there, right? I believe where we saw more benefit of a precision system was where we were going to lower seeding rate and narrow row spacing. So essentially that gives you more linear feet between your seeds. And that's where you see a higher benefit of going to a precision technology. In terms of, again, another cartoon on where our seed ended up, right? Soil depth here, going from pretty shallow all the way to 4 inches deep. You can see with broadcast, we were sitting all the way at the soil surface, all the way down to almost 3 inches deep. So we were pretty much all over the place, right? And you expect that. In drill, you can see we were better, but still all the way from 1/2 inch to almost 2 inches. And look at the precision planter. We were pretty much spot on, around at 1 inch or so. So we did improve our seeding depth, not the seed-to-seed spacing as much, right? So this is, again, just showing you one location. How about other location? So you will see a couple of these charts here in the next few figures. We did these trials in 21 and 22. In each year, you can see 5 different farms. And you can see the planting date for those farms as well, right? So overall, we have data from 10 on-farm trials that I will be showing you over here. And you can see BI's broadcast incorporation, then drill, and then precision planter. And we didn't have the precision planter at all of our locations. You will notice that it's going to be only at a subset of our farms. So this data is a seed depth variability. What that means is if it's a higher number, that means there was more variability in our data. If the number is lower, that means that's good, less variability. So first thing you will notice is that the precision planting graphs were the lowest at the locations where we had that. And then the second thing you will notice is that where we had the broadcast incorporation compared to drill, the numbers are much higher. So as we expected, pretty much at all of our location, when we did this broadcasting, we did increase the variability. So you would expect, as a result, our yield potential is going to be relatively lower in the broadcast, right? Because of this variability piece, right? Let's look at the yield data now. Same, again, 10 farms, 2021 and 2022 over here, right? First thing, again, you will notice is the precision planter. Wherever we have it, it's resulting in either statistically highest yield that shows this different lattice, or it was numerically higher than both of other methods. So it shows precision planting did help improve the yield potential. that we saw out there. Just give me 1 second. The second point you will notice over here is between the drill and the broadcast, there was no difference at any of our 10 on-farm locations. So you can see the yield potential varying all the from 140 down to 60 bushels or so. At any of those farms, we did not see a difference between drill and broadcast. However, the precision planter did give us a yield benefit, and we'll talk about why that might be the case. There was a question there. So yeah, for all of these trials, and I'll talk a little bit more about that. I think I have a slide on that too. We were keeping a similar seeding rate. Mostly we were targeting around 1.2 million when we were able to plant in that early window. When the planting was delayed, we were going up to 1.4 or 1.6 million, all right? But that's a good point because that leads into this slide. And this, I believe, is the driver why we saw a yield benefit or we did not see one, right? This slide is showing you effective tillers. So the tillers that were able to produce a decent size head and contribute to yield, right? So we believe this is the main factor that's driving our yield potential out there, right? The kernel, the size of the kernel head is going to be important. The kernel weight is important. But in most of our trials, to drive to a higher yield, we are looking at more effective tillers. And if you look over here, in precision planting, that number is highest in general, right? But compared to previous slides, here now you can see the broadcast is actually giving you a higher number. At a lot of these locations, we were able to get more effective tillers by broadcasting our seed. So it's again showing you, and I'll show you cotton on that. I believe again, since the seed is more uniformly distributed, it's able to produce more tillers that are producing a seed head even compared to a drill, all right? And this is actually going back to your point on seeding rate. So within broadcasting, we wondered, since we are dealing with the non-precise seed placement, can we bump up the seeding rate, right? So here, this is just data on Broadcast Incorporation. NR is our normal seeding rate, what I just told you. HR is a higher seeding rate. We went like 20 to 30% higher. And look at, again, this was not at all farms, about 6 or 7 farms. The yields are all A's, meaning statistically they are similar. So we did not see a benefit of increasing our seeding rate. You have a question, sir?
You see a little different yields with all these different technologies. Do you figure in a machinery cost?
That's a good point. So the question is about the machinery cost, right? We have been thinking about that. Dennis and I need to run some partial economic analysis on that, accounting for, if you're buying a new system or if you are manipulating what you already have on farm. That is the next step we are going to be looking into. And we have not done that analysis yet. All right, so again, this was another one we were surprised. We thought that we will see a benefit of higher seeding rate, and we have not seen. I'm showing you data from 2 years. The third-year trials are still in ground. So again, later this year, we'll have data from about, I think, 6 more farms on these same comparisons. Another aspect here on precision planting, this is research we did in small plots, not on farm, where we were looking at the effect of seeding rate and row spacing, right? This data is somewhat similar. Again, you can see the yield was maximized at 1 million or so. We did see a yield penalty by going to 500,000 seed. So it sort of agrees with the numbers I was showing you before. And we did see that for drill, that optimal number was a little higher than a precision planter, all right? But this is the main point I want to discuss over here. We looked at the row spacing. Using the planter, we can manipulate those row spacings, right? And I believe this is really making maybe the biggest impact in terms of the equipment we are using. You can see our narrow row spacing, 5-inch, is giving us by far the highest yield potential compared to 7.5, or when we went to those wide row spacings, right? People have done some 15-inch row spacing, right, using the existing equipment. So here you can see the yield potential is much lower than anything else we saw, including the 7.5, and especially compared to 5-inch, those 15-inch row spacings were at a yield disadvantage. Again, this is with everything else being the same, right? So you can manipulate maybe other management to minimize this yield loss, but it is there with the 15-inch row spacing. And this is why I believe that's happening, right? This picture taken in early May, you can see this 7.5 inches intercepting almost 75% of light, right? Compared to 10 inches, about the same. You didn't lose much, you didn't gain much. When we went to 15 inch, now we are less than 70%. So we are not intercepting as much sunlight, right? Look what happens in 5 inch. We are almost at 90%, right? We are intercepting much more sunlight by going to narrower spacing. And this 15 inch, even late, we took a picture on June 10th, we were still in mid-70s. So we were never able to close the canopy in a 15-inch row spacing, and that's showing that yield loss I just showed you. And then a higher potential in 5 inch right there, right? So again, this is sort of, to me, a good take-home slide. Seed drill, if we sort of think about, we are planting 7.5 inch rows. I believe this is drawn using 1 million per acre seed rate. Your seed to seed spacing is less than an inch, right? And you have some skips, some doubles. If we go to a precision planting system, especially I believe the main component here is the narrow row spacing. Now you can see we have more seed to seed spacing, right? So just like corn or soybean, now the plant has more space to work around, and it can produce more tillers that can produce those heads we are looking for, right? This actually looks more close to maybe this ideal. In a perfect world, this is what a plant, maybe just like us, wants, right? An equal space around it, not being stuck in this row pattern, right? But we don't have technology to go there, right? I don't know, maybe in 10, 20 years we'll have these robotic systems that can do something like that, and maybe that's where we will be. But in the meantime, maybe this is what broadcasting is doing for us, right? As long as we are able to uniformly distribute that seed out there, right? If we do a poor job broadcasting that seed, that's going to be worse than anything else we can do, right? But if we can achieve something like this, seems like the wheat plant doesn't really mind. You still have the issue of the seeding depth over here, right? You're getting a good 2D, but the 3D, the depth is still not there, right? And that's something, again, we still need to figure out. We have done some seeding depth work, you can see over here, just to answer that question, how critical is seeding depth? So we have done these studies where we go all the way down to less than an inch, all the way to 3.5 inch, right? Over 2 years, you can see the maximum yield is generally in this 1.5 inch. It wasn't different in the second year compared to half. It was lower in the first year with that shallow depth. So there is a trend there, but if you look at these numerical averages, the differences were pretty minimal. We were within 5%. By going to shallow or deeper, we didn't lose as much of a yield potential. So again, seems like it's not as critical. It is helpful to maintain a good seeding depth, but it's probably not as critical as maybe giving plant that more spacing around it, so it can tiller efficiently and produce effective tillers, right? So to combine these two, again, we already talked about the early planting, right? I showed you those yield losses. And that, to me, is the number one factor out there. We can achieve this early planting by using these faster planting technologies, right? There are negatives with that, but we can at least achieve faster planting. But I believe longer term, this is where we want to be, using more precision systems in narrow rows. I believe narrow rows is even more critical than the optimal seed placement to maximize yield potentials. And at least from our data, it looks like we have a potential to reduce our seeding rates, right? Based on those, again, planting windows, if you're in early, mid, or late season, and what that optimal is looking like you, right? We always recommend, throw out a strip out there that's 20, maybe 30% lower than what you are doing at your farm, because some of the yield limiting factors might be different, right? Your soil type, your tillage will play a role in that. But maybe throwing a strip out there will give you some idea about what that optimal is probably for your farm, for your variety, right? And again, this question about, we still need to figure this out. The economics of it, if we have a planter out there, is it better to reconfigure that or versus going to a new system, right? We know that if we go with a 15-inch row spacing, there is a yield loss. We know that. And if we go to a narrow row spacing, 5 inches, there is a yield benefit there, right? So the economics is probably going to be dependent on a given farmer, but again, something we'll probably look a little bit more into. Any questions, comments? I have a few more slides after this, but I think this was the main one.
Okay, so you talked about seed depths. Let's say we're going 1 inch versus 2.5.
Yep.
You got ideal conditions after you plant that you have enough moisture to sprout the seed.
Mm-hmm.
Once you go in, being that some emerges quicker than the others, is there any difference or test when you go to harvest as far as moisture on that wheat? Because with this weather conditions now, if I gain a week of harvesting time, plant 1 inch versus 2.5, that's a lot because we get these storms. So is there any data on that?
Yeah, that's a good point. So the question is about like if our seeding depth is different, 1 versus 2 inch, will that have eventually an impact on our moisture when we harvest that? So we have data. I haven't looked at that aspect. My hunch is, or my feeling is that we did not see much difference, that the wheat was able to compensate for that. There is a difference. We actually went out and every day we rated, how much wheat is coming out of the ground. In 1 year, the 3 inch was much delayed compared to 1.5 inches. Another year, it was actually there wasn't much.
Apples for apples.
Yeah.
You get the great moisture.
Yep.
Last time
Yep.
you had 1 inch,
Yep.
you had a quarter inch, it'll germinate. But
Yep.
you might, for that 2.5,
Yep.
you may need a half
Yeah.
inch, 3/4 of an inch rain to get down to seed depth. So I would think there would be a lot of difference
Yeah.
in maturity
Yeah.
as you go.
Yeah. So that is a fair point. Again, I think that, there's a benefit again. I still believe there's a benefit of that uniform seeding depth, right? At least it provides this uniformity, and we have seen that in one of our precision planting trial, where it was, I think 2019, it was a high fusarium year as well, if you all remember. And we had some decent dawn levels in our data. I think we cut down our dawn levels by almost 30 or 40% by going to a precision planting system, because I believe we had similar seeding depth and we had uniform emergence and uniform tellers. So the efficacy of the fungicide you're applying, the timing, that flowering we are targeting, I believe we did a better job getting that. So I think there is a benefit still with that optimal spacing. It might vary again based on your soil type and given the year's weather, right? All right. So the question is, did we notice a delay in maturity with the late planting? I believe there was. Dennis, you recall, it's able to compensate for, it's not the same in terms of number of days, but there was, I believe, at least a week or 10-day difference, right? For our planting day trials, we actually did harvest 2 different times. We got our planting day 1, 2, and 3. I think we were able to get them, so there was minimal difference there. But 4 and 5 were definitely behind. So that does happen, and we have noticed that consistently. All right. Okay, I have 5 minutes, so I probably try to finish this. So this is the third and final topic. This is still some ideas out there, right? Where is the next 5 bushels going to come from? And I assume Eric talked already a little bit about that. Something that's pretty exciting to me, but again, it's still a potential, right? We still need to get more data to validate what we are seeing. If I were to show you these 4 pictures, what's the first thing you notice that's different between these? Canopy, right? So it's the canopy, so it's a genetic trait. And what Eric tells me, it is genetically controlled. So he has genes that can manipulate this. So we can, again, management does play a role in terms of your canopy, but a lot of it is genetics. So I think there's a hope there that he potentially can breed varieties that look more like this compared to maybe something like that, right? And this is, again, a canopy scale that he has devised, going from a scale of 1, where we are calling this, droopy types. Your leaf angle is very vertical. It's pretty much parallel to the ground. Compared to if you look all the way over here, this rating scale of 5 is that your leaves are more vertical. Just like what you see in the corn hybrids nowadays, right? We have done something similar already in corn. The question is, can we benefit from a similar trait in case of wheat, where we have not done enough research looking at this aspect. So again, it's a collaborative project. Eric and I are involved. Dennis has been there, and we have a couple of folks from Ontario looking at this same aspect. And hopefully we'll have some good results for you all here soon. Again, going back to the idea, you see this is your canopy, what we call droopy, where that leaf angle is pretty vertical, right? It's parallel to the ground compared to this more erect types over here, right? So you might be wondering, okay, so what, right? So this goes back to, again, those three components, intercepting light and converting that into biomass, right? So this is the depth of your canopy. This is sitting at the top, and this is at the bottom of that canopy, right? So this first one, this droopy one, you can see as we start going in deeper into the canopy, you're shading it pretty quickly. So the leaves at even the middle or the bottom of the canopy, they are shaded. They are not contributing to the overall yield. If anything, they might be respiring, right? Compared to this erect type, here you can see even at much depth, you still have some light level that's available. So that's the idea, is that with these erect types, can we benefit by improving the use efficiency of light that we are intercepting, right? That's the idea. And some work that recently came from Australia, this is their figure. Canopy architecture, their 1 is opposite to us. Their 1 is erect, 10 is droopy. And what they were showing that between these two, there was 100 grams per meter square difference. That turns out to be about 15 bushels or so. That's a pretty big number, right? But again, that research was done on spring wheat and Australia. Again, relatively dry, much different climate compared to us, right? We have looked a little bit into this, and we saw the seeding rate response, and that was different. So we're asking all these kind of questions, you know. Pretty much the bottom line is, can you guys include that as part of your variety selection? When you're looking at, 5, 10 other things, does variety canopy type needs to be part of that? And does it need to be on a seed label, eventually, that you pick a 1, a 3, a 5, and so on, right? And some of the management we're targeting is planting time, seeding rate, row spacing, even intensive management, right? Some data here quickly. Again, we have seen that based on our canopy scale, in 1 versus 5, we are intercepting different amount of sunlight, right? With 5, those erect types, even at the bottom of the canopy, we still have some sunlight, just like what I was showing you before. And we have done some of these planting date studies here. These data are from the late planting. Here you can see these types at the top, they are your droopy ones. The ones at the bottom are erect types. So we are seeing that with the delay in planting, now your goal is to intercept more light, right? Because you don't have enough season in front of you. These droopy types potentially can benefit. If you're planting early, maybe going with these erect types might be beneficial. So again, some initial data, some data even here, seeding rate response, we are seeing that this Branson is more of an erect type. So we are able to put more seeds, fit more plants in a unit area, just like what we can do in case of corn, right? With these erect types, we can push to a higher seeding rate. So we are seeing a little bit of that in here as well. So I believe this is my last slide. So again, we are seeing that this trait is genetically controlled and we can breed for it. When we look at most of our varieties, they are actually droopy types. If you talk to Eric, I think 80-90% of our varieties in his breeding lines are droopy types. That brings the question, do we need to spend more time looking into these erect types, right? And in terms of, again, management decisions, we are thinking, again, planting time. If we are able to plant early, I believe those erect types might be beneficial. Because your goal is not to intercept as much sunlight, your goal is not to let the bottom canopy shade out. And the erect types can do that. Delay planting, you might want to go for a droopy type, right? Seeding rate, again, pushing to higher seeding rate, just like corn, it might be beneficial to go with the erect type, right? Row spacing, same idea. We are close now, right? It's probably more beneficial to go to an erect type. If we have a 15-inch row spacing, it's probably better to go with the droopy type. Intensive management, that's the one that Eric probably showed you some data. Again, there's probably a benefit of going with these erect types because you're developing a thicker canopy, right? If you have erect varieties, they probably will shade out less at the bottom compared to a droopy type. So something maybe for this year, if you have a plot that you're thinking about intensive management, if it has this erect leaf type, there's probably a higher potential to get a response compared to a droopy leaf type. So again, that's sort of the ideas we are chasing here. We have some hypotheses, but we want to make sure that we have more data to take this to the next level. Any questions, comments on this idea? And again, more of this information will be available on our website, agronomy.msu.edu. So please, again, as we start getting more data, you can go and check out the information on that website. And again, I would like to thank everyone in the team. It takes a lot for us to get this work done, starting with funding from you all. So I would like to thank Michigan Wheat and pretty much all of my team. Thank you.